Trident 3 works, right? And today we would be seeing some Broadcom level commands. So today will be today we'll mostly focus on like the packet flow. So we will discuss L2 L2 unicast packet flow, what like how the packet would flow within the pipeline. We'll also check like how would L2 unknown unicast packet flow would look like, and then we'll also try to cover like unicast routing and also try to cover one VXLAN flow. So before starting like with the session, so do you guys have any questions related to the previous session? Okay, cool. So if we like remember last time Advait asked a question, and so this So this was like Advait's question, right? So for now we can try to concentrate on the like topology here. And what Advait asked was like we have a host one here, which is part of VLAN 100, and the IP address is 10.0.0. Let's say 5, and he is the host is trying to communicate with its gateway, which is configured on CD263, where we have a SVI 100, and we have virtual MAC configured, right? And my virtual IP is 10.0.0.100, right? But like the condition there was like EG, like the host one was not directly connected to its default gateway, right? It had a device in the middle, let's say CD262, right? And on that device, we have SVI 200, we also have SVI 100. So we have SVI 200, just VLAN 100, sorry, no SVI. So we have SVI 200, VLAN 100, and a virtual MAC configured. And the virtual IP is 20.0.0.100. And all the ports between these devices are trunk ports, right? And then like what Advait asked us is like when host one tries to reach its default gateway, the behavior that he was observing is the packet was getting dropped on this guy on CD262. The packet was getting dropped, right? And the reason why the packet was getting dropped, like the packet that host one was sending had a destination IP of 10.0.0.100, and the destination MAC, which was destination MAC for that packet was the virtual MAC, right? And since the virtual MAC was also configured on this device, uh, uh, the device would check its like my station TCAM, right? It would check its TCAM table and it would realize that the destination MAC of the packet is present in its my station TCAM, right? And if that is present, then the device would do two things, right? Like it would understand that either it needs to route the packet, or otherwise the packet would be destined for itself, right? And in this case, since the vmac is configured on this mac, this device will like consumes the packet, right? Because it does not know how where 10.0.0.100 is connected, so it would consume that packet and basically drop the packet, right? So any questions on that scenario? Like, so this was the question that Advait had asked, right? And then I tried to check a few things internally, and this behavior this behavior is observed until T2, right? Because I also checked the same thing on Trident 3 box, right? And I was not able to I did not see drops there. So basically, this is my T3 setup. Again, same setup where SVI 200 and VLAN 100 is present on MRV 420. SVI 100 is present here. So whenever host one tries to reach SVI 100, which is like host one again part of VLAN 100 tries to reach VLAN 100, and even if uh, here my Mac is not even if here my SVI 100 is not present, still Trident 3 is doing the bridging, but in Trident 2, like the bridging was not happening, right? And I was quickly able to like check this in the lab, and I was also able to see the like some similar behavior. So let's say this is EGV 360, which is my host, and now let's say it tries to ping this IP, right? Like which is my virtual IP, and I can see that my packets are failing, right? And if I quickly go on this guy, and so here, if I do show LLDP neighbor, your EGV 360 is connected on ET5/1. So we will just check for like any platform level drops on Ethernet 5/1. So platform. Okay, so at the moment we can see like this are some previous drops. Now I would again source a ping, and now I would so now we send basically we'll try to send like 5 packets, right? And here we can see that there's a like 100% loss. But now if I try to check the packets, I can see my IPv4 L3 discard has incremented, right? So non-congestion, like as we discussed a couple of sessions ago, that non under non-congestion discards, we would see different kind of discards, right? For example, if on this interface there were some packets which were dropped by the field processor, then we would have expected to see those here as well. Like basically there would be one more field which would say that packets dropped by FP. But if let's say there were 10 packets, then this value would be 20. But here, like the drops that we see are can be seen here under IPv4 L3 discard. And every time if I again try to send 5 packets, right, I would again see this drops incrementing, and my communication is not happening. So basically, like what is happening here is, since the VMAC is present in the my station TCAM profile, this device would consume the packet, and then as it does not know how to reach 100.0.0.100, it will drop the packet, right? It wouldn't send the packet here. So to overcome this, we have a TOI, right? And the command to overcome this behavior is platform Trident L3 routing MAC address per VLAN, right? So this is the command. Now what this command will do is, even if the packet comes up with a VMAC of like with a VMAC which is configured on this device, but it will still check for additional entries, right? And if it matches those entries, then it will bridge the packet, right? So for example, now after configuring this command, let's say I run the ping again, and this time if you can see my my ping was successful, so I did not drop any packet. My ping is successful. And if I run the same platform layer drop command again for 5/1, I did not see any increments here. Now my good L2, L3 unicast packets increased by 5, right, which went out from here. But but I did not drop any packet. So so this is basically a behavior, right, which is in T3 we don't need to configure this command, but like on T1, this is how we can avoid the scenario which like Advait asked us earlier. So we also have a show command just to check this. So the show command is show platform Trident L3 Yeah, like if you can check this output, so this output will only be seen if this feature is configured, right? For example, if I do a no to this command, then I don't expect to see any output for this, right? Like the output is blank. But as soon as I configure this command, I can see the output here. So basically, this output is like showing me the entry like the entry for the VLAN where it has like router MAC and VMAC configured, right? And if we can see, VLAN 100 is not present here, right? So that's why like even if we receive a packet with a VMAC, but which is for VLAN 100, we would bridge the packet, right? Instead of dropping it. Any questions here?
Pratik, just to confirm, so this is the case when we have virtual MAC address configured, but no virtual router address IP, correct? On CD 262.
Yeah, so CD262 does not have a SVI for VLAN 100.
Got it, but it just has the virtual MAC configured.
Yeah. It has a virtual MAC.
Got it. All right. Thank you.
Oops, where is my? Oh, okay, typo. Yeah, so it has a virtual MAC configured, but does not have a SVI for VLAN 100, whereas this guy has the same thing.
Got it. Thank you.
Thanks, Thiru. So yeah, so this was what Advait had asked, and so basically this behavior, like just again, just FYI, this behavior is only till T I think Trident 2 and Trident 2 plus, but from T3 we don't need to we don't need this feature. Uh, cool. So let's move back to our Trident 3. Let's and here we would be discussing the packet flow. Right. Like so quickly let's go through this. So how the basic, this is the basic L2 pipeline on how the packet, what happens when the packet comes in. So as soon as the packet comes in on the ingress port, we assign it a SVP, which stands for like a source virtual port. Then a VFI is assigned based on the VLAN, and so if it's a trunk port, then the VFI assigned would be like the .1 queue tag. If it's the access port, then the port, the port which is part of that access VLAN would be configured here. And if it's a L3 port, then internal VLAN would be assigned. Then the L2 lookup would happen, and the L2 initially we would learn the MAC based on the source MAC and the VFI, which we see in show MAC address table, right? Uh, then the next phase would be to learn the DMAC and the DVP DMAC and the VFI, and from that VFI we would derive the DVP uh, and based on the DVP we know where we need to send or what would be the egress interface. If let's say the flow is like unknown unicast, so that we don't have the MAC entry in the table, then we would use IPMC, which we discussed last time, which is something called as IP multicast, right? And based on so there were four fields there, which was unknown unicast, then which was unknown unicast, unknown multicast. Then unknown unicast was for like edge port. So edge port is basically which is not a VXLAN port. Then unknown unicast core was for like where when we would be used when we have VXLAN in the environment, and same goes for the unknown unicast and multicast. So we would be discussing all these pointers like in detail in the upcoming scenario. And then we get the next hop table based on the DVP. On the DVP table, we would get the next hop. And then based on that next hop, we would get the egress port, and then we would send the packet out. So this is like the basic L2 pipeline on what would be checked when the packet comes in until it goes out, right, or until it is handed to the egress pipeline. So first we would talk about like with talk about a L2 unicast flow. So this is like a very small lab. What I have done here is I have already captured all the outputs. So we would be going through the outputs one by one rather than running the commands in the lab. Uh, This is my topology. WL414 is trying to reach WL413. Both the devices are here, let's say, in same VLAN, and CMV414 is my T3 device on which we would be checking all the outputs. Just the MAC address for CMV414 is AD83, and the MAC for WL413 is 1374. Right? Now, let's go step by step on how the packet flow would be, or what outputs would we check, or how the outputs would be programmed onto the Broadcom chip. So here we would try to associate the chip level commands with our show commands. So the way we see things in our show commands, right? Would is like pretty straightforward, but that's not the case when we are running the Broadcom level command. So what we would try to do here is check a show command, right? And then try to map or try to associate that show command to the Broadcom commands, and try to understand how things are done in Broadcom. So just a note, there are like a lot of fields in the output, right? I am not 100% sure of each and every field of the output, but what I have tried to do here is I have tried to like color code what field would be important in the particular scenario, and we would try to discuss that. So the color coding is just to associate what like at what point from where a value is derived. So we would get to know it, but now let's get started with this. So let's say WL414 sends a ping to WL413. Now the first thing that we would do here is as soon as the packet comes in, like the first thing that we do is we check the MAC address table, right? And from the MAC address table, we understand that we have this guy 0B94, which is our WL414, which is which is connected to ET14, and ET14 is part of VLAN 17. Right now, how would this be done in on the hardware level, right? Or in the chip basically. So when the packet comes in, the first thing that the switch needs to do is to assign a SVP, the source virtual port to the packet. Now, to assign a source virtual port, the chip needs to look at two different ports. So one port is source trunk map modbase, and the other table is source trunk map. Now, this is our first command. So this until here, the syntax of the command would always be same. So the how to read this command is like platform, then the chip name, right? Then diag stands for diagnosis. Uh, dump is just to dump the output, and chg stands for change. So change here does not like necessarily indicate that we are using this command when we are trying to make any change, right? Like we can also we in here we are also using so change. Yes, change gives us the power to change, like to make changes on the output on the chip level. But change here would also be to check the outputs or to see the output, right? So the first command that we would run here is platform Trident diagnosis dump change. And then the first table that we would see here is the source trunk map mod base, right? Now from this table, I am more concerned in this output, right? Now from this output, I what I need to do here is take the base value, right? So this is my base value, and the port for which I need to find the SVP, I need to add the value into my base value, right? So if you can see here, my base value is F78. Now the next thing is to add the logical port ID into my base value. So I run the command show platform Trident interface map. From this command, I get my logical port ID, right, which is 14. Now, since this is hex value, I convert 14 into hex, which converts to E. And now when I add these two values, I get F86, right? So the next command, which the next table that we need to check is source trunk map. So I run this F86 against the source trunk map table, and I get my SVP, the SVP value which is assigned for that port. Right now, if I convert this hex value to decimal, I get 16320. Now, with the help of show command, if I need to check my SVP, so this is the command: show platform Trident VFI virtual port, and then I would check for my concerned interface, which is Ethernet 14. And as we discussed last time, right, DVP and SVP depends on the direction of the packet. So if the packet is coming in, then I would consider the it like I would give it assign it like a SVP, and if the packet is ingressing, then I would assign a DVP. Right here in the output, even if it says DVP, but since we are checking ET14 in ingress, we this value would be our SVP value. Now, with the help of show command, we get 16320, and this is how we can derive the SVP based on the from the Broadcom, basically by running the Broadcom commands or from the Broadcom shell. This is how the SVP is derived. Any questions? Like, is it confusing or is it clear? Cool. Thanks, Rupa. Now, so now, the next thing would be to assign a VLAN, right? The next thing in the pipeline would be to assign a VLAN, and as we discussed, VLAN can be assigned in like three different ways. One, if it's a trunk port, then the tag with which the packet comes in, that would be my like VLAN or VFI. If it's an access port, then there are steps on how we can find out that, or how the chip understands that. And if it's an L3 port, then based on the internal, like we will assign an internal VLAN, right? Now, to once the packet comes in on ET14, right? Let's say ET14 here in this case is an access port. So I've just pasted the config here, and ET14 is part of access VLAN 17. So what I do is I run the port number for the for this over this table. So this command remains the same. So D stands for dump here, dump change, and then port 14. So from this port, I get my L port profile ID, right? So L port stands for logical port. So I get my logical port profile ID, and now I need to run this value over my logical port table. And when I run this through my logical port table, I get the port like port VLAN ID or the port VID which is assigned. And in this case, it is 11, right? And again, this is a hex value. So if I convert this hex value to decimal, I get 17, and like 17 is my basically VLAN 17 is ET14 is configured as an access port for VLAN 17. So this is how we can check from the show command, or we can also do show VLAN. But if you want to check this from the Broadcom level, like these are the commands or these are the tables that we need to check in order to find the port VID or the VLAN ID which would be assigned to the port. Here I have just used like added one more example. So let's say if we want to check the VLAN ID or the port VLAN ID which would be assigned if the port was a trunk port. So in case whenever the port is trunk port, the port value or the port VID value in the L port table will always be 1. So here I have tried to run this command on ET13. So 3D so 3D would like the hex or the decimal, sorry, 3D is the hex 3D is the hex for ET13, and ET13 we can see here is my trunk port, and same like I can confirm from here. So when my port VID is equals to 1, I understand that okay, this this port is trunk port, and the same can be confirmed from the running configuration. So the next step after the VLAN is assigned would be to check the CML flags. So the CML starts for like CPU managed learning, and like the simple way to understand CML is like CML helps me to understand if that interface should learn the MAC or not, right? So what we do is we run the three FA. So this value which was derived from here, oops, where is it? Yeah, so which was derived from here, like which is my SVP. So I would run the SVP value here on this table against the source VP table, right? And from the source VP table, I would get this CML flags. And if my port or the interface is allowed to learn MAC address, right? Or if like when we learn MAC address would be like if it's L2 port, then it would be set to 8. So if it's 8, then yes, like I am allowed to learn the MAC addresses, right? So this
Oh,
is
hey, Pratik, 1 second. So I just have one question. The show platform Trident VFI virtual ports. You said it gives SVP output, right? Can you
show
scroll?
platform tried up.
Yeah, a little bit up. Yeah, this one.
Mhm.
So is this SVP output or DVP egress or how?
So basically we can read this as something like this, right?
Okay.
And what this would mean is if I am checking for from the ingress perspective, like if a packet comes in and I need to assign it a virtual port, that time I will assign it a SVP.
Okay.
If let's say my packet is going out via ET14, so that time I will assign it as a DVP. But like when we check the output here, this will always tell us that DVP. But we this would be like interpreted based on if the packet is coming in or going out.
Okay. Okay. Might have missed that. Thank you.
Okay, no worries. Thanks, Nikita. Okay, so we are done with CML. So now the next step would be to understand like the VFI attributes, right? So why we need to understand the VFI attributes is because we will understand this output more when we are like doing a unknown unicast scenario. But for now, like this is the command that we need to run to get the attributes, right? So platform trident diag d change, and then we need to check in the VFI table, and 0x11 is the hex value for my VLAN, and basically this is my VFI ID, right? And from this, I get my unknown unicast, the IPMC values here. The values from the IPMC output would be here, and we would see it in detail in the next scenario, right? Now, once the VLAN is assigned, once the VFI check is done, right? Now my next step. The next thing would be to check the spanning tree state, right? And also once the VLAN is assigned to the packet, now like as we discussed last time, once the VLAN is assigned, then the VLAN membership check would be done, right? And if the port if if that port can carry the packet with that particular VLAN tag, then only the packet would be forwarded or the packet would be dropped, right? So to check if the VLAN membership, the table that we would be using is ing VLAN VFI membership, and we would give it our VFI value, right? Now this output here, like I am interested in this part in this output, which gives me my bitmap. Now from this bitmap, what I am trying to understand is if the if the port on which the packet came in, right, and the VLAN of like or the VLAN tag of 17 has got assigned, since it is access VLAN 17. Now I need to check if it is part of like that port is part of VLAN 17, right? So how do I do that is from the bitmap. Now, if you can see, I need to start reading this table from here, right? So these are all the, like I convert them into binary. So 1 stands for 1 0 0 0, then 0 stands for 0 0 0 0, again this, and then 4 stands for 0 0 0 1. Now, this 1 stands for, like, if I have a SVI configured on the switch. So if VLAN 17 has a SVI configured, in this case, yes, it has a SVI configured. Like, this is not the output for that. I missed adding the output. But on this, on this switch, I have a SVI for my VLAN. So I make this one, right? Now from here, my physical port start. So this is port 1, port 2, port 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14, which is set to 1, right? Which means that, like, uh, the pack, if ET14 has a VLAN tag of this, then I can forward the packet, right? So this is how we read our port bitmap, and based on the bitmap, we can see that this is 1. So the packet would be now forwarded, right? Uh, So I just tried to add one test here because I was not very sure on how this one was working. So what I did was I tried to get rid of the I tried to remove the SVI. And once my SVI was removed, like now here, if you can see, there's no CPU here. So this bit went back to 0. This is no longer reporting 1 as in this case, right? And then this is how I would check our the spanning tree check would be done here. So show platform Trident VLAN spanning tree group STG, and here I can see that my Ethernet 14 is in forwarding state. So I forward my so basically now my, like, most of my ingress pipeline is complete here. Any questions? Is it like are you guys able to follow? Cool. So now, once that is done, now the next thing that we are interested in would be the L2 entry table, right? Or basically in simple terms, how this would be. So how the packet, what checks, sorry, what tables we would update when the packet comes in, right? And how how to read, or what will the Broadcom chip see now when it needs to send the packet out, right? So when the so here at this stage, there we will do two checks. The first check would be done on the source MAC and the VFI ID of the packet, right? And this check will be done in the L2 entry table. Similarly, for the second pass, so this is for the first pass, we check the source MAC and VFI. Similarly, for our second pass, we would check the DMAC and the VFI. So basically, this is where my port came in, and my DMAC VFI would be from where my port needs to, or my packet needs to go out. So what I do is I again run the same platform command, and in the L2 entry table, I can see this, right? Like, this is my source MAC. So my source MAC is 0B94, so which is here, and this is the VFI ID, right? VFI ID is the VLAN ID again, and the hex value of 17 is 11. So this is my first pass. Now for my second pass, what I'm interested in, three things here. First is my VFI, VLAN to VFI. The second thing is my MAC address, or my DMAC basically. And there's now a new field that we need to check is the L2 destination. So this will basically give me my DVP, right? So as we all know, if we just need to check based on the show MAC address table, we just need to run this command, show MAC address table, and here we understand that okay, the packet it will go out of if the packet can go out of VLAN 17, and if my destination MAC is sorry, if the packet is part of VLAN 17 and my destination MAC is this, I need to send the packet out of here, right? Like this is how we read it based on our show command. But now it's based on like our platform command. What we do is we first check this output, right? Now from this output, I can see that how do I understand that I need to check this entry is because based on my DMAC. So my DMAC is 1374, which matches here, right? And this is my DVP, right? So 3FAF. So here 1 stands for the module ID, right? And this is my hex value. I run this against the SVP table, the source VP table, right? And now from this source VP table, I I get this output, right? Here I am interested in this value, 16303. So now once we understand, right? Like once I understand that I need to send the packet out of ET13, and if we want to check from the like based on the like from the platform command, like not the Broadcom command, but like the show platform command, what we usually do is we run the show platform Trident TFI virtual port, right? And then we check what is the DVP for my egress interface, right? So I run show platform Trident VFI virtual port. I check the output for ET13, and what ET13 gives me is my DVP, which is 16303. And how the Broadcom shell comes like derives this is or knows this is basically based from this output. So from this, it checks the destination, which is 13, oh, sorry, 3FAF. Now I run it against my source VP table, and I get this output, right? Now what I need to do is I need to run this value or basically this value against my ing dvp table, right? Because this will give me my next hop index or nh index, right? Like this, because our packet. So like if you remember last time we talked about like now this is divided into overlay and underlay pipeline, right? So basically this value would point to should point to this, like this next hop group, and this is how my packet would go out. So the Broadcom shell will try to check this value, and from this value it would understand that this is for ET13, and then it will send the packet out of ET13. So how is this value derived is is what we will see next. So I run the platform command against my source VP table for 3FF, and I get 16303, which is my DVP, right? Now to derive this, I need to run this value against my ing DVP table. From my ing DVP table, I would get F002. So here I am concerned about my next hop index value, which is this next hop, right? The next hop index value. This value, when I convert it to decimal, it gives me 61442. Now the so which 61422, which points towards my underlay next hop, or from the and my underlay next hop would point towards how my on what interface my packet needs to go out, right? So once I get this value, I run this against the ing L3 next hop table, right? And the output that I get from this table, I am interested in this value. Now here 01 stands for the module ID. Here N0D, we need to convert it to decimal to get what would be my egress interface. And when I convert 0D into decimal, I get 13. So based on this, I understand, or the chip understands, that the packet needs to go out of Ethernet 13. And after this, the packet is given to the MMU, and then passed and then it passes through the egress pipeline. So like this is how So like based on show commands, it's like we just check maybe three or four based on three or four show commands, we would have been easily able to get this value. But like this is like these are all the commands that are run in background, all the Broadcom shell checks or the chip checks to understand like how it needs to send or how ET13 will be the interface that the packet needs to go out of based on the source IP, DIP, and source MAC, DMAC. So this was like my like our L2 unicast flow on how the flow would be, uh, or like how the packet passes or how the packet would flow within the pipeline and what tables are checked and how it is sent out of from the ingress to the egress pipeline. So this is like the end of the first scenario. Any questions or anything you would like to discuss about?
Pratik, can you scroll up
Sure.
a bit? Uh, so here we got the value, destination value of 0x13FAF, right?
Yes.
From that platform Trident Diag D CHT L2 entry. We have the L2 destination as that one. And then in this output, in this command platform Trident Diag D CSG 0 source BP, we have not included one, right? Giving this value.
So this
0x3FAF, that's what you have
so,
included.
so I think this one stands for the module ID. Like this is what I understood.
Okay, so we don't need to give the module ID when
No,
you're entering
no,
the.
I like because if we give one here, the output will be like very different. So we don't need to give one here. Now I'm like not very 100% sure on how like why it was excluded here, but like during my testing when I was trying this with one, I was getting a very like I was not getting any output, I think.
Mhm. So that
So,
one, this one that you give after 0x3FAF in this command, platform Trident Diag D,
so
the one is not the module ID here.
no, that's not the module ID.
Okay.
Oh,
Okay.
wait, sorry. Wait, one sec. I think this so here in this case, I guess yes, this is the module ID, and
Okay.
on this device, it is fine if we don't use this because we don't have like we just have one chip,
Module.
right?
Okay.
Yeah, one module. So, but yeah, you're right. Like this is the that module ID. So if I but even if in this like if I don't use this here on this platform or on this switch, I would still get this output.
Okay. Got it. Thank you, Pratik, for that.
Thanks, Rupa. Cool. Thanks. So we'll move on to our next scenario, which is what would happen if we don't know where we need to send the packet out now, right? So now the packet that comes in is like a unknown unicast for our switch, right? So in that case, like the first five steps would be exactly the same because that would be done on based on the source IP and the source and the based on the ingress point of view, right? So whatever is configured on the port, that VLAN I would assign, or if my packet comes up with a VLAN tag, then that's how I would check the VLAN membership. I would check the spanning tree state based on what interface the port came in. So the first five steps would be exactly same. What would be different here is from here. So if you remember, previously we discussed that at L2 entry table, we do two passes. So the first pass is for the source MAC and the VFI, right? And the second pass is for the destination MAC and the VFI. Now, when we are doing unknown, when the packet is unknown unicast here, we don't know the DMAC, right? And when the DMAC is unknown, we would have to rely on the VFI table, right? Which uses our IPMC logic, right? If and if I if these outputs are based on how we can check from the show commands, right? So show VLAN would so since it is unknown like a unknown unicast packet, I would flood the packet in on the ports which are part of that VLAN, right? So now I do show VLAN here. I can see ET13 and ET14 are like are part of that VLAN. Now, if ET14 receives the packet, I would flood it on ET13 and why, but not on ET14, right? So what I need to check next from the platform level is this command. So show platform Trident VFI MC index. Now, since this packet, so as we discussed earlier, UUC core and edge. So UUC stands for unknown unicast, and core would be when we have VXLAN configured or we have a VXLAN interface. Edge, we would check the value under edge when there's no VXLAN. And in this case, since we don't have VXLAN, our UUC core and the UUC edge have exact same value, right? Which is 24. Now to check, so based on this value, to check on which ports I need to send the packet out from the platform perspective, right? Or from the show command perspective would be this command. So show platform Trident L3 software M groups, and then in M groups, the value I need to give is this 24, right? And now this after running this command, I need to check this output here, and we can see that ET13 and ET14 are part of that group basically. So if I need to flood the packet, or if I need to flood the packet using my IPMC logic, I need to send the packet out on ET13, ET14, and what all ports that are part of VLAN 17. Here, if since packet came in on ET14, it will just go out of ET13. But here, this is just the output that shows us. It doesn't really tell us that on which interface the packet has come in on, and on which interface the packet needs to go out. Uh, so now this is how we would like this.
Hey, Pratik.
Yeah.
Hey, sorry, just to add one more thing over here. When you look at the output, so platform Trident L3 software M groups 24, you will see that the output is divided into two parts. You have L2 ports and L3 ports. So you will find your CPU is a part of an L2 port. That's always the case. But your other interfaces are always a part. They're always listed under L3 ports. And I think if you recall, we were saying that the IPMC replication logic is loosely based on L3 logic. So that is why you will find that all of your replication on Trident 3, wherever the tables are split into underlay and overlay, they're considered as L3 replication. That's why IP replication. But your CPU will continue to be a part of your L2 port. I just wanted to bring this to your attention. So it's normal to see it this way. Thank you.
Cool. Yeah, thanks for clarifying that, Sujit. We'll also see like a example, or like in the coming outputs, we will see this how the based on the port bitmap, how this is different. Right? But thanks Sujit for clarifying. So this is how we can check based on our show commands. Now, like from the Broadcom level commands. So the first command that we need to run is, like, I need to run my VFI ID, which is V17 on the VFI table. Right? From this table, I get I'm I will now be more concerned about this. I will be concerned about this output. Right? So UUC, so unknown unicast destination, and this is my value. If I convert 18, like the hex value of 18, I get 24. Right? So my decimal is 24, which matches with this value. Right? Now it matches with this value. Now, to understand the L3 IPMC logic for this destination, right? So there are like two things that need to match. So one thing is this bit should be set to 1, and what this bit is, like, this register should always be 1 for source port pruning to be true, which means that if this is set to 1, then I will never flood, or the switch will never flood the packet on the interface where the packet was received. So we will never flood the packet on the ingress interface. Rest we will flood the packet on all the other interface. So that is what this register or this bit stands for, right? Now, as Sujit mentioned, right, the L3 part and the L2 part of this output. So if you can see, L2 is the CPU, but L3 ports we have ET13, ET14. So also just to note, like this this ports, like the config under this ports is still like L2, so they are still trunk and access ports, but based on the IPMC logic, they would be considered as L3 ports, right? Now, when I run this command in my L3 IPMC table, right? If you can see, the L3 bitmap here does not have a 1 here. Like in the last bit, it does not have a 1. So my L3 bitmap is like 0006. But if you check the L2 bitmap here, it has a 1 here, which is for our L2 port, or which is for the CPU port. So 1 here would be like, when we convert it to binary, it would be zeros, like 0001, and that 1 would be our CPU port, as we saw in the previous example, right? But in case of our L3 bitmap, or from L3 perspective, if we try to like understand this bitmap, so I've just tried to break it down here. So 0006, when we convert it to binary, it would be 00000 and then 0110. So if we start from the port perspective, so first port, let's say for CPU, then this is 1 2 3 4 5 6 7 8 9 10 11 12, and then these are my 13 and 14. So 13 and 14, which are part of that VLAN, which are part of that port bitmap, are now set to 1 here, right? And this is what we saw here, 13 and 14. Right. So this is how the switch, like this is how the switch would understand on which port it has to flood the packets when when it is an unknown unicast packet for us, and we are using the IPMC logic, right? So I just tried to add like how the output would look different when we have VXLAN enabled on the switch. So if I quickly jump here, when VXLAN is not enabled, the unknown unicast core and unknown unicast edge are like have the same value, right? 24, and we don't see a VXLAN interface here. But as soon as I configure, oh, okay, I missed this output. As soon as I just 1 second. Yeah. So as soon as I configure VXLAN here, now my table changed. So I run the same command for VLAN 17, and now in this case, my unknown unicast core is now 13, and my unknown unicast edge is now 7. And since VXLAN is now configured, so earlier when VXLAN was not configured, my UUC destination, like my unknown unicast destination, was like this 18, which whose decimal is 24, right? But now when I have my VXLAN, my unknown unicast value changed. Now it will be 0C, right? And when I try to if I try to convert 0C, it should be 13, right? So my hex is 0C, my decimal would be 13. And if I try to check using the show commands, like what are the ports under my group 13, so here it will show. So here this is my like a normal port, and then this is my VX1 interface, right? Like basically my uplink or my core port. So here now my L3 port is ET14. Since I have CPU, I have that CPU in my L2 port, and now I have a additional port called as tunnel port, which is Ethernet 13, right? Which is my VX1, on which my VX1 interface is there. So when VXLAN is enabled, based on the IPMC logic, my switch understands that it has to flood the packet out on these ports. Let's say we have ET12 on which the packet was received. So it knows that the packet, we need to flood the packet out on these ports. by checking this value, sorry, by checking this value. But when VXLAN is not enabled, my switch will check this value, and based on the ports which are part of this M group, the packet will be flooded out on those ports. So, and then once we understand, once the switch understands the like on which interface it has to flood the packet, it sends it to the MMU where the replication is done, and then the packets are sent out via the egress pipeline.
Hey, Pratik.
Yes. Hey.
So, yeah. So, this last output shows where the packet is flooded to.
Yes, this one, right?
Okay, so all these ports, right? L2 ports, L3 ports, and even if there's VXLAN,
Another
then
point. Yeah. So it
okay.
this will tell us that where the packet needs to be flooded out. So here,
Okay.
because why I'm saying that is like in this case, I just have ET14 and a VXLAN, right? So let's say the packet would come in on either one of the port, right? Either it would come on ET14 or I, I would either receive it over my tunnel port. So I like when my flooding logic applies, I would just send the packet out of one port. If it was received here, I would send out of here, and if it was received here, then I would send it out of here. But this output would, yeah, you're right, like this output would give us like all the ports on which are part of that group where I would have to flood my packet,
Okay,
except the
and there
egress
was
port.
okay, and there was one output where there is if the flag is equal to one, then we won't flood it back, right? Okay.
Yes, so that was this. So okay, oh, okay, so I missed adding that. So now what we need to do is we need to run platform Trident diagnosis dump change L3 IPMC, and here instead of this hex value, we would need to use this hex value, right? Because 18, how we derived 18 was our unicast destination, right? Like from this output, we took this hex value,
Oh yeah, yeah, correct.
right? So same if you can see, not here. Yeah. So platform Trident diagnosis VFI 0 cross 11. Like this is my VFI ID of VLAN 17 when VXLAN was not enabled, and this is that output with VXLAN enabled here. Make sense?
Yeah, got it. Got it.
So
And for
yeah,
known VXLAN, we will see underlay and then DVP different, right? Sorry, yeah, next hop underlay and DVP different, right?
for
Uh,
known VXLAN,
yeah, if we are not flooding and if we know the MAC address
yeah. So
of the
here
node.
we have not like talked about DVP. So DVP
Okay.
would come after this here. Yeah, you are right. But DVP is different, and it would come after this. Like
Oh, okay.
once this is done, once the switch knows on what port it needs to flood the packet out, then it would like check how DVP would work or what the DVP would be for that packet before sending out the packet.
Okay, okay. In this case, it will be the ET 14 or 13. Yeah.
Yeah, yeah, right. Yeah. It would be T14 or 13, like anyone from that.
Okay. Thank you.
Cool. Thanks, Melvin. Uh,
Yeah,
so
Pratik, like I'm not sure if
hi.
the question is a silly one, but like the tunnel ports, right? It should have shown VXLAN when why it is like Ethernet 13. Like seeing Ethernet 14 under L3 ports makes sense,
Mhm.
but the ET13 under tunnel ports, it should have been VXLAN.
But my VXLAN, but ET13 is our uplink. So this is like when the
Mm,
packet would be sent out of that VX1 interface, that copy will be sent out of ET13.
okay. So
Yeah,
you
so
mean that VXLAN on this is the physical interface on which the VXLAN is terminating.
yes. So if you can see this diagram, like this is my VTAP. Let's say CMV414 is our VTAP, and the other VTAP is WL413, and then this is how they would talk. So ET13 is the let's say a L3 interface between them, and then that would become my VX1 interface. So in this case, ET13 is my VX1 interface, like kind of.
Yeah, the actual outgoing interface for the
Yeah,
VXLAN traffic.
yes.
If there are multiple outgoing interface, I mean multiple interface for that VXLAN, that means we'll have all those interfaces included under the tunnel.
Yeah, now I'm not sure. I would need to test it because like the reason why I said I'm not sure is like let's say if we have three uplinks, so we would see let's say ET13 like 10, 11, ET11, ET12, and ET13. So
Right.
now how the ECMP would work and how we would basically just select how the hashing would work basically, and we select just one uplink to send the packet out towards our spine. Yeah, I'm not very sure about that logic, but
Mm.
I think there'll be again we would need to run a few more like few more outputs or few more Broadcom commands to understand that. But I think we are not covering that like in
Got
this one.
got it. Yeah, thanks for that.
Good, thanks, Rupa. Uh, okay, so this was about the L2 unicast and L2 unknown unicast flow. So I still have like unicast routing and VXLAN flow. So like this again, these flows are like somewhat the same, right? Like the only difference comes when like the tables that we check, right? But the logic remains the same. So like what do you guys want to do? Like should we continue this session now and complete these two flows, or like are, I can share this doc, and is it okay if you guys can check it on your own, or like do we need another session? Like how do we want to proceed? Because like it's already 3:05,
How much more time would you be needing, Pratik, to cover these?
or maybe like so it depends on like 20, maybe 20, half an hour more.
Okay, I think half an hour. I know it might be a bit more because people would have planned their schedules for the day. So, can we have it in the next session?
Yeah, we can do that, but maybe like Sujit, like we
Yeah,
can check with.
I think that part, I think the working group can take a call.
Yeah, maybe I would have to discuss this with Sujit once.
Hey, I'm not sure. I mean, I'm okay if you go through this because 80% of the two flows are the same. So it's just about highlighting the differences. But I think whether we want to stretch to 15, 20 minutes, I think that the group can decide. But I'm okay with either. Because it's not very different. The basics is still the same, but just some differences. So the question is that are we okay stretching the session for another 20 minutes maybe? Or if we think that's too much, then we can reconvene the next week.
Sure, I think we can let the team answer because a lot of times I keep getting pings that they have other schedules. So I think we can let the team decide if they're okay. Like, if you guys are okay, please give a thumbs up. Okay, I think we should be good then. Please go ahead, Pratik.
Cool. Thanks, guys. So, yeah, now I'll just go a bit fast, and if there's like any questions, please stop me. So the next scenario we can discuss is L3 unicast routing. Again, the device that we are concerned here is CMV414, right? And you know, now for my routing, this is the like I'm checking the route for my destination, which is 30.30.30.2, which is configured on this device, and then we are learning it. This is my ET13 is my trunk port, which has VLAN, which is allowed for VLAN 10, and 10.10.10.20 is SVI for VLAN 10, which is configured on WL 413. Just give me a second, guys. I'll be back in like 5 seconds. Okay. Sorry. Uh, so this is how we usually check any routing, anything related to routing. Like usual commands are like show IP route. Do I have a route? And is my like ARP resolved for the next hop, right? And here we can see like everything is looking fine. But now let's have a look from like the from chip level on how things work. So here the L3 IIF. So L3 stands for L3 because we are discussing routing here. This is derived from like the VFI value and which makes the routing decision, right? So how that is done is first thing that we do is we run our usual platform command against the VFI table, and 0A is my 0A is the VFI value, and the 0A VFI value is based on this VLAN 10, right? Like basically based on VLAN 10. So the hex for VLAN 10 is A, right? So from when I run this command, I get my L3 IIF value. Now this L3 IIF value, no, yeah, okay. So the L3 IF value is how is derived from this output. Then the next thing I need to check is my in the L3 IIF profile table, right? If my IPv4 L3 is enabled. So this helps us to understand like if this bit is set, then that would mean that routing is enabled. So what I do is platform Trident, and then in this L3 IIF table, I run this for like the VFI value, which is for VLAN 10. And from that, we can see that the L3IF profile index is set to 1, which means that routing is enabled for that VLAN or that VFI basically. Right? Now, the next, it also says here that we also need to check the L3IF profile. So this is the command to check like the L3IF profile table. And here we can see that IPv4 L3 is enabled. Okay. Oh, oops. Sorry. Actually, I missed. Like this is not output. This is the output. So we in the L3IF profile for that VFI ID, we need to check if IPv4 L3 is enabled, and like if it is set to 1. So if it is set to 1, then routing is enabled. So from this we can confirm that this is set to 1. So routing is enabled. Now the next thing that we need to check is so the IPv4 L3 must also be enabled for the SVP. Now, if you can see, I was checking this for VLAN 10, which is my basically egress, right? Like this is how my packet would go out. So I was checking for from the DVP perspective, but we need to also check the same for my SVP. Now, like how our SVP is calculated is exactly the same thing, right? Where we first check the base from the source trunk map and then add the logical port ID. So in this case, since the setup is exactly the same, so my SVP would be, or the interface that on which my packet would ingress would be ET14. So from that, I get my the SVP value, and then I need to run that value, run the SVP in the source VP table, and from that I can see that also for my SVP, routing is enabled. Basically, IPv4 L3 is set to 1, right? So now once I confirm that my routing is enabled, now the next thing that we need to check is our my station TCAM, right? So again in my station TCAM, like in this output, we would be considered about like if the destination MAC belongs to my MAC, or if the destination MAC is part of the my station TCAM profile. And we on one thing we would also check is in this my station profile 2 table. So what first table is my station TCAM 2, where we would check if the DMAC is my MAC, and in the my station profile 2, we need to check is IPv4 termination is allowed, right? So CMV414, like this is the MAC address of CMV414, which is AD80, AD83, right? And which is, so if I run platform trident command against my MyStation TCAM2, against my MyStation TCAM2 table, I get this MAC address entry, and I get this destination value. Now we just hold on with this destination value for now. This will be used later. And I will also check my station profile too for IPv4 termination allowed set to 1. So from this, I can see that my IPv4 termination is, it was set to 1. Yeah, here. So IPv4 termination allowed is set to 1. Right? So once this, and like once this check is done, now the next check that we would need to do is to send the packet. Basically, now this would be based on like where the packet needs to go out of, right? Like now this would be if, like, what is my destination MAC, what is my destination IP, and how the packet would go out. Because here from until here we were able to confirm that the, like, based on the entry, my station TCAM entry, I was able to confirm that okay, the MAC address, the DMAC of the packet is my MAC, so I need to route the packet. I also confirmed that in my SVP, from my SVP perspective, routing is enabled. So I can route the packet. Now we need to check on how do we get the egress interface, or how the packet would be sent out, right? So the first thing is we check the L3 L3 entry single table. So if I had to check based on the platform commands, like the show platform commands, this is how my route would point to, right? Basically 10.10.20, 10.10.10.20, which is my next hop, has a position of 1164. Like we will be using this value in one of the outputs, and then my next hop ID here is 47, right? So now what I need to do is I need to use this, like this value, against my L3 entry single table. So what I do is I run platform trident diagnosis against this 1164, the hex value, against my L3 entry single table, L3 entry single table. And from this output, I am concerned about like this bit. So here, if you can see here, so destination, if the destination is unicast pointing directly to next hop, then I expect a value something like this, where 3 would indicates it's a next hop, and and the other value would indicate the next hop ID, right? So now if I come here, so this 3 will be, which indicates like it is for the next hop, and then 2f when converted to decimal becomes 47, which is my next hop ID. Does this make sense? So just checking. Yeah, so this is how like this output is read, right? Once like I get my next hop, once my next hop ID is there, now what I will do is I will check the next two tables. One would be the initial L3 next hop, and the ing L3 next hop table, right? I need to check these two tables. Now these two tables will give me my DVP, right? So how is, so first thing, so the first thing that we do is we run the platform trident command, and then in the ing L3 next hop table, I I use this hex value which was derived from here, right? Which is my basically my next hop ID. Now that next hop ID gives me this value, like 0, like hex, and then 13 FAF. Now this is my module ID. I convert this hex value, which converts to decimal of 16303. Right? That's one thing here. Now my 16303 is my this output, is my DVP. right? Now, if we remember, like in the packet that needs to go out would be sent out of this next hop group. Like basically in unicast route. Oops, sorry. Earlier, what we saw is when the packet had to go out, we need this, like the chip would check this value when the packet would be sent out, right? And this value is usually mapped to our egress interface. Similarly, in this case, what we need to do is we need to run the like our like the platform trident command against the ing dvp table, right? With this hex value, which is my dvp, right? And when I run this, I get my next hop index, which is F002. So when I convert this value to decimal, it gets converted to 61442, which is my basically underlay next hop, right? Through which my packet needs to go out. So 61442 will be mapped to ET13, and that's how the packet would be sent out by this device. So this is how unicast routing would work. So until here, sorry, yeah, the first five steps would be like almost similar. Then we check the SVP, DVP. We also try to confirm is if routing is enabled. Then we check the my station TCAM. If the my station TCAM, if the MAC belongs to my MAC, we also check if the IPv4 termination is allowed for that, like basically for that VLAN or that VFI. And then from there we try to work our way to finding the DVP and the next hop value, and that's how this value is associated with our egress interface. And once we have this value, the packet would be sent to like out via the egress interface, basically to the egress pipeline, which would then eventually send it out of ET13. Cool. So if there are no questions here, we can move on to our next flow, which is our VXLAN flow. So in again, like here as we saw, right, like the difference that was like the difference here was the checks that were done, right? Earlier we were checking the L2 entry table. Then if we have the source like SVP, we check the SVP and the VFI. Similarly for sending the packet out, we check the DV yeah, we check the DMAC and the SVP, or the sorry, DMAC and the VFI. And based on that, we try to find what the egress interface would be. In terms of routing, the additional thing the additional checks that were done is to confirm if routing is enabled. And then next thing, we also check my station TCAM, right? And based on that, so the commands, like the commands are like pretty much there are not a lot of commands, right, that we can use here, but it's just about the flow, how the flow is, right? Like uh, in the last session we discussed, right, how life of a packet and how the life of a packet changes when the packet is doing routing, or the packet is just sorry, when the switch is doing routing, or the switch is just like it's just a unicast flow, right? So these are the three things. Sorry, these were the three flows. And now again, in VXLAN, flow would have its own bit of checks that we would have to do. So again, this is my topology for my VXLAN flow. CMV414 is VTEP1, WL413 is my VTEP2, and ET13 would be basically my VX1 interface. Now the VFI VLAN source VP assignment, again in this case, is exactly the same. We don't, like, nothing changes from that perspective. Now here, one different thing that we would do is, so this is like this VXLAN flow is again for L2, right? Now if you remember, when we were talking about the L2 unicast flow, when we were doing the like the two passes, right, like in the L2 entry table, we checked the L2 entry table, and there we were able to see, like, associate our ingress associate our SVP, right? And we're associated the VFI with the source MAC, and based on the second pass was destination MAC and the VFI. And based on these values, we tried to find what our egress port would be, right? And in VXLAN, we would be doing the same thing here. And how VX1 like how we find VX1 is like is in the later section. Like basically is we would get to know from these commands. So the VFI, VLAN, and source VP, everything is same. Then in the L2 entry table, the first check would be again be same, which would be done on the source MAC and the VFI. Now the check for the destination would be a bit different. So here, if you can see when I run the platform command against the L2 entry table, this is my MAC address, like basically my egress MAC, which is here, right? And this is my VFI, which converts to 17 when I convert hex to decimal, and now I get this L2 destination, right? So I will use this value now to find my DVP and everything. So the next thing would be to convert this hex value to decimal. So 01 is my module, and then I need to convert one FFF. So when I convert one triple F into decimal, I get 8191. Now, what I need to do is I need to run this 8191 by my source VP table to understand to understand if I should be to understand the CML programming, right? And then if CML, if the bits in CML are set to 8, then I know that I need to learn MAC address on that interface. So this check, if you remember, was not a part of our when we were doing routing, right? So I run this 8191, which value I got from here, against my source VP table, and I was able to get my the CML values. Also, one thing to note here is the SVP profile index needs to be set to 1, which is set to 1 here in our case. So this output is just basically to show that you we get the same output if we give the input as a decimal value or a hex value. So it doesn't really matter if it is not like we always need to convert the hex to decimal and then run it as an input, right? Here we if you guys can see the exact same command, and here I'm using decimal, here I'm using hex, and I get the exact same value, right? Once my CML check is done, now I would check the next two tables, which would be my ing dvp table and ing dvp2 table, which would give me my vp, right? My virtual port type. Yeah, I think it stands for VP, virtual port. So my VP type, and then if we are doing VXLAN, or if my egress interface is VXLAN, then this VP type should set to be VP type should be 3, right? So when I give 8191 into my ing dvp table, I get my VP type is equals to 3. So this helps me to understand that this is a VXLAN, or the packet needs to go out via the VXLAN interface, right? And I also get my next hop index. So we will be using this next hop index again to find our egress interface, right? So here, so I use my next hop index in the next command, which gives me my the next hop value, right? So now what is the significance of this value is basically for this command. So if you can see, show platform trident VXLAN next hop. So this tells me that if I need to send a packet to this VTEP, which is 2.2.2.2, which is our destination VTEP, then the next hop ID here is 61499, right? So when I converted not sorry, I did not convert. So when I used my when I used the SVP value against the against the ing dvp table, I was able to get my next hop ID. And if I need to run like a normal platform level show command, then this is the command to get the ID. But this is how Broadcom would get it eventually, right? Now again, we need to check the destination here, and this destination. What we need to check is again here 01 would be our module ID, and 0D would get like 0D is the hex value for decimal 13, and 13, which we know is our egress interface or over which VXLAN is configured. So this is how we get our Ethernet 13 basically. So this is how Broadcom knows that if it needs to send the packet out of, or the chip knows that if it needs to send the packet out of of over VX1, then the packet needs to go out of ET13. So until here, now we have our egress interface, right? So now I know where the packet needs to go out of. Now the next thing that we would be considered is from where the chip understand, or from which table the chip refers to find the outer source IP, outer DIP, right? Like how it builds the outer header. So to get the outer destination MAC, to get the outer destination MAC, the chip would refer to this table, right? The chip would refer to this table, and the input would be our next hop, like or the input would be our DVP value, right, which is F03B, and from here I get my basically I get my outer DMAC, which is this, right? Similarly, if I need to find the outer destination IP, what I need to do is I need to run the same command, but now I need to run it over the egress DVP attribute table. And from this table, I will get my VXLAN destination IP. So here this is shown as 202022, but like this would mean that this is my outer VTAP IP, basically VXLAN destination. So this would be converted to 2.2.2.2. Similarly, if I so this is how I get my outer DMAC, outer DIP. So if now I am left with outer DMAC, outer DIP. Now I am left with how I select my outer like the egress tunnel IP or outer source IP. So for that, this is the table that we refer to. So egress IP tunnel. So based on this tunnel, I would get my like the tunnel source IP, or basically the outer source IP. And here one thing that we need to check is be aware of the tunnel type. So if tunnel type is B, then it would mean that it is a VXLAN tunnel. Right? So and how so this is how we get this. Oops, these three values. This would be my switch MAC, right? So we don't need to derive this now. And one more thing here would be the VNI, right? So the VNI is derived from this table. So the egress VLAN translation one double table, right? So what I tried to do here is like the output was pretty big, like when I was trying to run this command. So I just tried to grep with 75, and like I am not 100% sure if I'm reading this output correctly, but based on the VFI value, so here we know, right, like my VFI is 11, which converts to 17, right? So okay, sorry, not 17, one sec. Oh yeah, right, sorry. So my VFI value is 11, which converts to 17, and my VNI, like the VLAN to VNI mapping is something like this of 17 to 117. So for VLAN 17, my VNI is 117. Now when I try to run this command, I get my correct VLAN, and if we check this VNI ID, we get like a pretty big number. But when I try to convert this value to decimal, I was able to get 117. So my understanding is like this is how we convert, like we would understand what would be the VNI ID for the packet from this table. And once we have like, this is how in VXLAN flow we build the outer header. For the inner header, everything would be like exactly the same that we have discussed earlier, right? But from VXLAN perspective, this is what is different based on what we have discussed earlier, and this is how we are there. And once we have all the information, again the same thing, the packet is like given to the egress pipeline, and then the packet is sent out. So this was like all from my side today. Any questions? I'm not sure if I was like able to explain everything in detail, because like there are a lot of different outputs here, and it was like very hard for me to like remember what the switch will check next. I try to use color coding just so that I know what next or what output next I need to check for. But yeah, I hope this was a helpful session for you guys.
Indeed, Pratik. In fact, thank you very much for all your efforts into this and for the interesting presentation. Thanks, Pratik.
Cool, yeah. So thank you everyone. I'll stop sharing now.
Hey, thank you, Pratik. Just one small thing. I think there is a lot of information being shared today. I think the objective of a session like this is not to be able to remember everything, but it is able, I think the objective here is to be able to understand, so that you can always go back to a document like this and look for what you want, so that the next time when you're looking at this, it's not very overwhelming. So that's perhaps the objective of a session like this. But thank you so much, Pratik. Really nice.
Thanks, Sujit.